Hello and welcome. In 1994, the Gang of Four published the Holy Grail titled Design Patterns, Elements of Object-Oriented Software. This book presents 23 different design patterns divided into 3 different categories. Creational design patterns deal with the creation of an object. Structural design patterns provide a formula for combining many objects and classes to create a larger structure. And behavioral design pattern provides solution for the better interaction between objects. Even after 30 years, this book is still valuable in the software industry, especially in a world when new frameworks come out every year, and understanding patterns is more important than ever. In this video, I will go over 4 design patterns that every developer should know. I will also walk you through the Python examples so that you can fully understand how these patterns work. So without further ado, let's dive in. First, we have the factory design pattern. The factory design pattern is a creational design pattern that allows us to create objects without exposing the creation logic to the client. If that sounds confusing, I will go over an example and clarify it for you. Imagine you are shopping for a laptop. You may know the brand of your favorite laptop, but you don't know what operating system it uses or what microprocessor is installed. You can delegate that task to a third-party service and they will make the laptop for you. That is called a factory. So I have prepared some example here. Alright, so first we have the operating system family. We have a class called OS here, and this class taking a variable called OS, and it has a method to return the string representation of the operating system. After that, we have 3 concrete implementations of the operating system: Mac OS, Windows, and Chrome OS. Secondly, we have the chip family. This class have a variable called chip, and it returns the string representation of that chip. After this, we have 3 classes: M2 chip, AMD chip, and Intel chip. Now we're gonna create the laptop. So laptop is an abstract class, so that's why I inherit from the ABC package. Each laptop we have a brand name, and it also have an abstract method to display the information about the laptop. Next, we're gonna have the Apple laptop. So the Apple laptop inherit from the laptop class. So I'm gonna call the constructor of the superclass and passing Apple. And then each laptop needs to take in the operating system and a chip. And I also implement the display method. So Apple laptop is using self.os operating system and self.chip microprocessor. We repeat the same process for Dell laptop and Google laptop. And finally, we're gonna create the factories. This is the meat of a design pattern. So we have an abstract class called laptop factory here, and it has an abstract method called create laptop. So this method basically will create a laptop instance, and we will implement this in each concrete factories. After this, we're gonna create 3 concrete factories: one for Apple, one for Dell, and one for Google. So for Apple, we basically create an Apple laptop, and the Apple laptop use Mac OS and M2 chip. So I'm gonna pass in these 2 instances here. The Dell laptop factory use Windows and AMD chip, so I'm gonna pass that in too. And finally, we have the Google laptop, which use Chrome OS and Intel chip. And finally, it's time to use our factory. So I have a method called create laptop factory here, which take in the brand name, and depending on the brands, we're gonna create the corresponding factories. So let's test this. I create 3 factories: Apple, Dell, and Google, using this helper method, and I pack them into a list called factories. And for each factory, I'm gonna call the create laptop method to create a laptop and then display the information about that laptop. So you can see that the client doesn't need to know any details about this laptop. He only needs to know about the brands, and the factory will take care of the rest. Let's test this. Alright, you can see that Apple laptop is using Mac OS operating system and M2 microprocessor. Dell laptop is using Windows operating system and AMD microprocessor, and the same thing for Google Laptop. So this is how factory design pattern is implemented. Next up, we have the observer design pattern. So in this design pattern, we have a subject and a list of observers. An observer can subscribe to a subject. When there's a change in the subject, all the observers will be notified. A standard example of the observer design pattern is YouTube. If you're on YouTube, you may subscribe to at least one YouTube channel. If you don't, you can subscribe to my channel. Seriously, each YouTube channel has a handful of subscribers. When a new event comes up, for example, a new video is released, YouTube will automatically notify all subscribers. So I have prepared some code here. So we have two classes here. The first one is YouTube channel and the second one is subscriber. So each YouTube channel have a name and a list of subscribers. So when we first start, we have 0 subscribers. So I initialize this variable as an empty list. We can also add a new subscriber in. So we basically check if the subscriber is not in the list of subscribers. We're going to add the subscriber in. We can also remove an existing subscriber. So we're going to check if the subscriber is already in the list. Then we're going to remove it from the list. And finally, we also be able to notify all subscribers. So what we do is we loop through all the subscribers and then call the update method in the subscriber class. And what do we do in this update method? So we just tell the subscriber that the channel just released a new video. So I'm going to test this logic. Here I create a YouTube channel with my name and 3 subscribers. Then I will add these 3 subscribers to my channel and then notify subscribers. After that, let's say subscriber 1 decides to leave the channel. So I need to remove him from the list of subscribers. If I release another video, I will notify the subscribers again. So let's test this. So you can see that when 3 subscribers subscribe to my channel, all of them receive a notification. But when subscriber 1 leaves the channel, only subscriber 2 and subscriber 3 receive a notification. So this is how we use the observer design pattern. Next, we have the Singleton design pattern. The Singleton design pattern is a creational design pattern in which we only have one instance of a class. This design pattern is useful when we only need a single point access across the application. So for example, the Singleton design pattern can be used to implement a locker. In many software systems, logging is an essential component for recording events and debugging purposes. A logger class can manage login operations throughout the application. It ensures that only one instance of the logger exists and all parts of the system can access it easily. So I have prepared some code here. We have a Singleton logger class which contains an instance. So this instance represents the actual object of the Singleton class. And in the constructor, I'm going to raise an exception. The reason being, for Singleton, we only have one instance of the class. So we cannot use a constructor to create multiple instances. In order to create a new object for a Singleton class, we have to use a method called getInstance. And this is a class method. That means this method only belongs to the class itself. It doesn't belong to the instance or the object of the class. Because we decorate this method as a class method, we will have access to the class. And if the class instance is none, so if this variable is none, we're going to create a new instance of the Singleton. And notice here, I use the new method instead of the init method. So in Python, this method is executed before the init method. And this method actually creates the instance of a class. So if we call the new method, this method will not be triggered and we will have a new instance of the class. And because this is a logger, I also have a log method which brings the message to the console. So I have prepared some tests here. We create two logger, logger 1 and logger 2. And I call the getInstance method to get the instance of the Singleton. Then I check are they exactly the same using the is operator. So let's run this file. And we can see that two objects or two lockers are exactly the same because we create them using the Singleton design pattern. So let's say in here, I create a third locker. But now instead of using the getInstant method, I use a normal constructor. So let's run this. Right, you can see that the exception has been raised. Right, so this is a Singleton, you get instant instead. So this is how you use the Singleton design pattern. And finally, we have the Facade design pattern. The Facade design pattern is a structural design pattern that simplifies the interactions within complex software systems. In this design pattern, we have a facade object that handles all the complex logic behind the scene and provide users with a clean interface to use the system. This design pattern is used a lot in modern technologies. So for instance, Git provides a facade object allowing you to track your code's history. React handles the DOM manipulation behind the scene so that you can focus on writing the front-end logic. And Django simplifies database interactions with high-level Python objects. I have prepared some code here. So let's say you try to create a payment feature for your website and you accepted 3 different types of payments: PayPal, Stripe, and crypto. But each payment gateway have a different way of handling the payment. So for example, PayPal use a method called process payment, Stripe use a method called pay, and crypto gateway use a method called make payment. They all do the same thing, but because they are developed by different companies, so they have different instructions and different standards. If you want to implement all the payment methods, you have to know the detail about all of these payment gateways. The Facade design pattern solves this problem. In this pattern, we're going to create a facade object called payment facade. And in the constructor, we're going to initialize 3 payment gateways: PayPal, Stripe, and crypto. And we also have a method to process the payment. And depending on the gateway that the user provides, we're going to process the payment accordingly. So this way, we're going to hide all the complexity behind each of these API and provide the user with a unique API to process all the payment. So let's test this. First, I create the facade object. Then I process the payment using different methods. So first, I pay $1,000 using PayPal, then pay $2,000 using Stripe, $3,000 using crypto, and $4,000 using a random gateway. You can see that everything works. So we pay $1,000 processed via PayPal. We have $2,000 processed via Stripe, $3,000 processed via crypto. And for the final payment, we're going to return invalid gateway selection because we don't have a gateway called random gateway. So this is how the facade design pattern works. That's it for this video. I hope you enjoy it. If you like the video, please like and subscribe. That supports the channel a lot, and I will see you in the next video. Peace.